Number 3 on the after test extra practice chapter 4. 2 10 kilogram boxes are connected by a massless string that passes over a massless frictionless pulley as shown above. The boxes remain at rest, that's an important statement there, with the one on the right hanging vertically and the one on the left 2 meters from the bottom of the incline. That makes an angle of 60 degrees with the horizontal. The coefficients of kinetic friction and static friction between the left-hand box and the plane are 0.15 and 0.3 respectively. You may use G equals 10 meters per second squared, and they give you what sine and cosine is, and we use calculators. Hey, what's the tension in the string? They want to know the tension right there. What's that tension right there? Since it's not moving, I know that down is 100 newtons. Since it's not moving, I know that up has to be equal to 100 newtons, which would be the tension. Since all a pulley does is reverse the direction, the tensional force must be 100 newtons. It's that simple. It's not moving, so that's important. On the diagram below, draw and label all the forces acting on the box that is on the plane. And so I think I have 2 boxes on there. I decided to have you do both. So I've got an upward tension and a downward force of gravity or weight, which in this case is 100 newtons. And on this one, I have an upward force of tension. Same as the red tension. I have a normal force that's going to be 90 degrees to the incline. And I have a force of friction pointing down this way. And then it asks me to determine the frictional force, the magnitude of the frictional force acting on the box. Well, I know that the frictional force, this is A, this whole thing here is B. C is just frictional force equals the coefficient of friction times the normal force. So I have to know the normal force. Well, normal force is equal, on an incline, this is always true, is equal to mg cosine theta. In this case, 100, because it's a 10 kilogram box, times cosine of 60 degrees. That is going to give me 50 newtons, because cosine of 60 is half. So the normal force is 50 newtons. Now I'm going to take that and multiply it by the coefficient of friction, which is the static, which is 0.15. So 0.15 times 50 newtons is going to equal, where this right here is the coefficient of friction. So times 0.15, that gives me 7.5 newtons. I think that might be different than what's on your test because it's not moving, so we have to use the coefficients of friction, static, kinetic, and static. Oh, 0.3. No, that's the wrong one. Hold on, let me erase that. This is 0.3. So 0.3 times 50 gives me 15 newtons. Yeah, that's the answer, which I think is still wrong. I don't know how I got 13.4 on it, but it's 15. Yep. So 15 newtons pointing downhill, but they don't care about that. They just ask for the magnitude, which is just the number. All right, the 10 kilogram box on the right, the hanging one, is now replaced by a 20 kilogram box. Find the acceleration of the system. Right, to do that, I've got to redraw these. So I'm going to just use the ones I have here. I'm going to erase. Oops. And this is going to be 200. And nothing's changed on this except for the coefficient of friction for kinetic friction is 0.15. And so the frictional force frictional force is actually equal to 7.5 when it's moving, when it's accelerating. If it's moving at all, whether accelerating or constant velocity, that's going to be the kinetic friction, which is 7.5, which is normal force, which is 50, times 0.15, which is the kinetic friction, coefficient of kinetic friction. So you get 7.5. So let's write our equations out. I get Ft minus 7.5 minus, there's one other one I got downhill here, which a lot of you guys missed, and that's mg sine theta, always pulls it downhill. So I've got to do 100, actually, let me just extend the page. So 100 sine of 60 degrees is going to be 86.6. 86.6 newtons minus 86.6 newtons. That has to equal m times a, which would be 10a. I'm going to make it positive because it's accelerating up the incline. I'm going to call it up the incline positive since I called down the incline negative. That's the reason these two are negative right here. All right, I got two unknowns there. Let's rewrite it. Ft minus, what's 86.6 plus 7.5? And we get 94.1 equals 10a. All right, and then my red equation would just be Ft minus 200 equals, I've been putting units, so let me erase that, equals negative 20a. Remember, this is now 20 kilograms. I'm going to multiply through by a negative, or you guys can use substitution if you'd rather do that. And my end equation is going to be 200 minus 94.1, which gives me 105.9, which equals 10 plus 20 is 30. 105.9 divided by 30. Acceleration is 3.53. I don't think that's the right answer. I think I have the wrong answer on your, I must have things in my calculator wrong somehow. So there is my answer. Yeah, I see what I did wrong. For 20 kilograms, I put 2 kilograms. So anyway, that's the right answer, is 3.53. To get my tension force, I just take this number and put it back in an original equation. I'll put it in the green equation. When I do that, I get Ft basically equal to 35.3 plus 94.1, which gives me 129. And that's how you do that problem. The D part, which is all this down here, that was a lot harder than the first part.